In this video, you will learn how to solve absolute value inequalities. On this first slide, it briefly introduces us to the concept of absolute value equations and inequalities. In that first row, it talks about the math sentence, the absolute value of x is equal to 2. This indicates to us that x either equals positive 2 or negative 2. And if we wanted to graph this, I could put a point at negative 2 and a point at positive 2. So the value of x is 2 or negative 2. The next line says that the absolute value of x is greater than 2. This is saying that the distance from that x is from 0 is going to be greater than 2. So if I wanted to graph this, I could say that in order to be more than 2 units from 0, I would have to be talking about either being more than 2 units to the right or more than 2 units to the left. So this inequality would be x is less than negative 2 or x is greater than positive 2. And the last inequality says that the absolute value of x is less than or equal to 2 units from 0. So what that's saying is that I'm talking about a number that is either somewhere that is either 2 units from 0 or less. So if I included negative 2, that's 2 units from 0. And if I include positive 2, it's 2 units from 0. And to be less than is including all of these values in between. So my inequality would be negative 2 is less than or equal to x, which is less than or equal to positive 2. Now we can use the information from the previous slide to help us create generalizations of how these absolute value equations can always be transformed. Whenever we have something where it says x, the absolute value of x is greater than or equal to, that means it's going to be an or inequality. Or something like a divorce. And what that means is that we're going to have two separate inequalities going in opposite directions, just like we have with our compounds inequalities before. And if we have something that was either less than or equal to, we can think of that as being an and inequality. And a way to help us remember that is to think of a sandwich. We would consider two different points and we shade in between. So if it's greater than, it's divorce, so it goes in opposite ways. And if it's less than, it's going to be a sandwich, so we're putting the variable and everything in the middle. Now let's review the steps to solve an absolute value inequality. First, you're going to wrap up the absolute value bars into a present and solve to get the present by itself. Then you're going to write two separate inequalities. One will be the inequality without the absolute value sign, and the other one, you're going to write the inequality without the absolute value sign, but you're going to flip the sign and take the opposite quantity of the number on the right. So essentially, you're typically making it negative. Then you will solve each inequality, sketch the graph of each inequality separately, and then determine if it's going to be an and or inequality, and graph your final inequality. In this example, we're given the inequality, the absolute value of p minus 3 is less than or equal to 5. Now our two different inequalities, one will be the exact inequality without the absolute value bars. So we have p minus 3 is less than or equal to 5. And for the other one, we're going to take the absolute value bars and get rid of them. So it's p minus 3. However, now we have to flip the inequality sign and make the number negative. So the two key things we're doing here is flipping the inequality sign and taking the opposite sign. So in this case, that means making it negative. Now we'll solve these two like we normally would. So to solve the one on the left, you would add 3 to both sides. So you get P is less than or equal to 8. For the inequality on the right, you would add 3 to both sides as well. So you would have P is greater than or equal to -2. And now we're going to sketch the graph of each of these separately. So if I have P is less than or equal to 8, I'm going to go to 8, put a closed circle, and you're only going to sketch part of the graph so we know which direction it would go in. Since it's less than or equal to, it's going to go to the left. So we're just going to sketch a little bit of this graph. Then for the other inequalities, P is greater than or equal to -2. So I put my closed circle at -2. I'm going to sketch a little bit of this graph. Now we can see from looking at that these two inequalities are going to run into each other. So the final inequality is going to be that the center is shaded. So you're going to extend that inequality, only shade the middle, and you're using those two closed circles as your endpoints. Now you could write the compound inequality. So you'd have -2 is less than or equal to P, which is less than or equal to 8. For our next example, we're going to do the same thing. So we have the absolute value of n plus 7 is greater than 8. So we have n plus 7 is greater than 8, because we just rewrite it without the absolute value sign. Then on the other side, we take what's inside the absolute value, flip the sign, and make it negative. Now if I solve, I would subtract 7 from both sides. So you'd have n is greater than 1. For the other side, we would subtract 7 from both sides. So you would have n is less than -15. Now if we are to graph, we're going to graph them separately. So I have n is greater than 1. So I'm going to find n, put an open circle, and shade part of the graph, so it'll be going to the right. For n is less than 15, I'm going to find -15, which will have an open circle, and shade part of the graph. And now we see that the graphs are going in opposite directions. So our final graph is we're just going to continue them in opposite directions. So we'd have our open circle at -15, draw our graph to the left, and then we have our open circle at 1, and draw your graph to the right. So if we were to rewrite this as an inequality, we're going to write them as two separate, like our standard OR inequality. So we can say that n is less than -15, or n is greater than 1. For our next inequality, we're again going to write our two separate inequalities. So we'll have 8m is less than or equal to 24, and 8m, we flip the sign so it's greater than or equal to, and make the 24 negative. Now if we solve them separately, we're going to divide both sides by 8. So we'll have m is less than or equal to 3. Divide both sides by 8 for the other one. So we'll have m is greater than or equal to -3. Now we're going to graph them separately. So for m is less than or equal to 3, we'll have a closed circle at 3. And we'll shade part of our graph, so it'll be pointing to the left. For -3, I'm going to have a closed circle at -3. I'll shade part of my graph, so it's going to the right. Now we can see that these lines are going to run into each other. So our final inequality is we're going to have closed circles at -3 and 3, and we are shading the area in between. So to rewrite this as a compound inequality, we'll have -3 is less than or equal to m is less than or equal to 3. For our final example, we're going to follow the same set of steps. So we'll rewrite our two separate inequalities. So we have -4x minus 10 is greater than or equal to 10, and negative 4x minus 10, we flip the sign so it's less than or equal to, and we make it negative. Now to solve them separately, we'd have, for the one on the left, we'd have to add 10 to both sides. So we get negative 4x is greater than or equal to 20. And then to solve for x, we'd have to divide both sides by a negative 4. However, when we divide both sides by a negative 4, you have to flip the sign. So my inequality becomes x negative 5, and my inequality sign flips from the original being greater than or equal to, now it becomes less than or equal to. To solve the other inequality, I would have to add 10 to both sides. So you'll have negative 4x is less than or equal to 0. Then you would divide both sides by negative 4. So you're going to have x gives you 4. And then both sides you have to flip the inequality sign so it becomes greater than or equal to, because we're dividing by a negative. Now if we were to graph these two separately, we're going to follow the same set of steps. So for x is less than or equal to negative 5, I'm going to put a closed circle at negative 5 and shade part of the graph. Then for x is greater than or equal to 0, I put a closed circle at 0, shade part of the graph. And then we can see they're going in opposite directions. Since they're going in opposite directions, we're going to continue and extend our graphs. And then we'll rewrite this as our final inequality. So x is less than or equal to negative 5, or x is greater than or equal to 0.